Hey, so we're going to learn about limiting reactants today. Limiting reactants or limiting reagents. It's an introductory video. Sorry about the dogs. And I want to start with some definitions. So, limiting a reactant or limiting a reagent is the thing that runs out first in a chemical reaction. So, oftentimes, when you have a chemical reaction, you don't have perfect amounts of your materials. You have one thing that you have run out first, and the other thing that's left over is the what we call the excess. So the excess reactant or reagent is a substance that you have extra amount of or leftovers after the reaction is complete. The other term that you need to get down is the theoretical yield. The theoretical yield is the amount of substance, the product that you're going to be able to make given whatever amounts of starting reactants you have. So, how much of the final thing can you actually make from what you start with? And just a word of note before we go on, the limiting reactant does not necessarily have to be the substance you have less of in the beginning. Sometimes the thing that you have more of actually runs out first. And so you have to look at how things react with one another. So the classic example of limiting reactant we're going to look at is the bologna sandwich. Now, I know that some people like their bologna sandwiches with different amounts of substances in it, but our bologna sandwich is going to have two slices of bread and one piece of bologna. And so if you look at this diagram here, this is kind of like our chemical reaction for the bologna sandwich. I have two pieces of bread and I have one slice of bologna. And if I take my reactants here, so my reactants are always on the left hand side. I have bread, I have bologna, and my product in this case is going to be the bologna sandwich. So my equation is going to be two slices of bread, two breads plus one bologna give me one sandwich. Okay, so it's like two bread, to be or not to be, one bologna. I'll put BA for bologna, and that gives me one sandwich. S for sandwich. Okay, so what is my hypothetical situation? Suppose I have 10 slices of bread and I have 7 slices of bologna. And the question now is, how much product can I make? So if I just look at the bread, how many sandwiches can I make with just the bread and not thinking about the bologna at all? Or how many sandwiches can I make with just thinking about bologna, but not thinking about the bread? So see how much you can make out of each one. And then you think about, well, which one's going to run out first? So if I do this reaction and I make bologna sandwiches, well, how many bologna sandwiches can I actually make? Well, let's take a look. So let's say I take two pieces of bread and one piece of bologna. Well, that's one sandwich. And another two pieces of bread and a bologna. Another two pieces of bread, bologna. Bread, bologna, bread, bologna. Well, what one did I run out of first? I have bologna left over and I ran out of bread. So even though I had less bologna to start with, my bologna is actually my excess reactant. My bread is my starting reactant, my limiting reactant, and this is my final equation. So I can I can make 5 bologna sandwiches. That's my theoretical yield for bologna sandwiches. My bread's my limiting, and my bologna is my excess. So let's switch to a chemical example now. And the one I'm going to look at is ammonia, the formation of ammonia. Ammonia is NH3. It's a compound used in cleaning. And the chemical equation for this is nitrogen, N2, reacts with 3 hydrogen molecules, 3H2, and that forms 2 molecules of ammonia. So N2, one of these, reacts with 3 of these, and then they split apart. Everything breaks apart. All your bonds break. They reform back together. And my 2 ends go, I have 2 ends here. There's one here. There's one here. And then my H's get split up. And so now I have 2 ammonia molecules. So this is my balanced chemical equation for the formation of ammonia. My reactants are nitrogen and hydrogen. And my product is ammonia. So now, if I look at my starting amounts, let's say I have 5 molecules of nitrogen and I have 12 molecules of hydrogen. What one am I going to run out of first? So which is my limiting reactant? Which is my excess reactant? If you think about what you can make out of each one, how much ammonia can you make with just the nitrogen? How much ammonia can you make with just the hydrogen? And then figure out which one is less. Okay, so I'll give you a second to think about that. And let's go and figure it out. So I have N2, and remember, it reacts to 3H2. So let's say I take an N2, one of these, and it's going to react with 3H2s. So 3 of these are gone. And then I say another one, and I react with another 3. Whoops, I didn't cross off. Okay. Another one, react with another 3. Another one, react with another 3. Well, now you can see I ran out of hydrogen first. So my hydrogen is my limiting reactant. My nitrogen, I have an extra one here, my excess reactant. How much ammonia can I make in the end? Well, if I count it all up, for this nitrogen here, so let's say for this one here, I made 2 NH3s. I'm just going to put a little bubble to kind of signify I made 2 of these. Another one here, so another 2. Another one here, another 2. Another one here, another 2, and that's it. I made 8 ammonias, and so I made 8 of these. I used up 4 of these, and I used up 12 of these. And you can see, well, look at the ratios here. This is a 1 to 3 ratio. Okay, 1 to 3 ratio. 4 to 12, that's a 1 to 3 ratio. So you just multiply 4 times 3. Also, 1 nitrogen for 2 ammonias. That's a 1 to 2 ratio. And I take 4 here and I double it to 8. That's a 1 to 2 ratio also. So you can see some different examples of limiting reactant. The next video that I'll have shown to you is going to involve some calculations involving more complicated problems.